lot of things plugged in now.
Good morning. It's 9:30, so we're going to get started. Welcome to DETNET. Thank you for staying until Friday. We have, I'm Lou Berger, Pat Thaler, and Janos Farkas is joining us as a new chair. We'll talk about chairs in a moment. Our secretary is remote. See if this works. There we go. No, that's... So we're actually going to start out by calling Deborah. Surprise, surprise. So we've seen this a couple of times, but this is DETNET. This is Pat's working group. So we really want to pay a special tribute and thanks to Pat, as we've heard, that who's retiring. So Deborah.
Well, as I think all of you know by now, at the end of the week, Pat is retiring, she claims. Goes on. Okay, so as we know, Pat's retiring, and while we're very sad to say goodbye to her, we do wish her all the best and happiness going forward. So we have something for her, card. And then because she only brings a carry-on with her, we purposely got her something really heavy. So, but it's small.
Thank you.
And so really thank her for this. She really kicked off the DETNET and really made sure we stayed with IEEE. And yeah, I have on the slide, I mean, she's much more beyond the DETNET. She has been the go-to person for IETF for anything on IEEE. Most importantly, she helped kick off the coordination group in 2012, which has made a huge difference in the relationship. We just had the meeting this morning. We meet once a week, even here at IETF, and it really makes things go smoothly. And it's really, of course, the people involved, and Pat's one of those people. Anyway, we think 50 was her first IETF, probably could have been earlier. And in 802, they had a big thank you to her because she is known to have been the one to have, she's chaired and held leadership positions the most of anybody, the most varieties. So we were really thankful to have her here as our DETNET chair for these first couple of years. And going forward, of course, we have a very good Janos to continue on, but we will miss her. So thank you.
Thank you. I can use this for my workout routine. Thank you all. Make me proud. Let's get this thing finished up. So I hope we'll make some good progress on this today. Thank you.
Thank you so much. So here is our note well. It's the end of the week. Everyone should be familiar with it, even though it's a new form. If you're not, please take a look at the link on the bottom and read about it. So we are doing audio and video streaming. We're also doing our joint minute taking through Etherpad. I just sent the link to the list, so if you want something easy to click on, just click there. It's also in the Jabber room, which I will do my best to watch. If someone else can jump on Jabber, that would be good, because sometimes I am busy focusing on the discussion rather than Jabber. The Etherpad link, I want to emphasize, is very helpful to make sure that we capture the discussions that go on. The presentations, well, we have slides, we don't need to worry about that, but the discussions are pretty important to capture. Particularly in this one where we're expecting a lot of discussion in the second half. If you make a comment at the mic, just jump on Etherpad and make sure that the comment was appropriately captured so that it's reflected in the minutes. That would be very helpful. Thank you. And of course, sign the blue sheets so we get appropriate room size. Our first session, excuse me, is a bit packed. This is definitely an eye chart. The point of this is we have a lot to go through, and we'll try to stick to our agenda. By the way, we'll have 2 remote presentations. Our second session is a little different. We are going to have a real working meeting, and we're going to try to confirm some of the discussions that have happened in interims since the last meeting. We have had 3 of them, and also highlight issues that are still open. And we would really like to try to close on what we think the direction is of the working group. And as always, we don't do final confirmation of decisions in here. We do it on the list. So the discussion follows on 3 interims that took place. We will have hopefully a good discussion, make some progress here. The results of that progress will be captured in a document, and then that document will have an opportunity for everyone to review and comment on the list. So that'll be the focus of the second session. We're going to adjust the timing a little bit, partially to allow for for Stuart Bryant to talk a little bit about his enhanced VPN framework, which we expect to show up at TEAS, but actually answers one of the questions we have on our slides is we need some text covering the VPN behavior we've always talked about carrying TSN over DETNET. And that's going to provide a higher level framework of it. So we want to make sure to give some time. We'll put that at the end, as well as, if we have time, this other presentation on control plane, which is definitely out of scope of the working group, but it's good to be thinking about where we're headed, particularly as we're trying to develop our information model and Yang parameters for describing service and describing nodal behaviors and link behaviors. As always, we really like discussion on the mail list. And we have an IPR disclosure process where basically before adoption and before working group last call that we ask all authors and contributors named in a document to explicitly state whether they know of IPR. This is also the time, if you're working in the working group and you know of IPR, and you can look at the definition in the note, what that means, know of IPR. If you know of it, that's the time to disclose it if you haven't done so before. So where are we in our documents? We have 3 documents that we keep saying we're going to last call, and this time we're not kidding. We really want to last call these 3 documents. We thought we were going to be into last call on 2 of these, the architecture and the use cases, but each time we went to really start the last call, the author said, we have one more thing to do. In the case of the architecture document, we think we're there now. In fact, it's not on the agenda for that reason. We think it's done. I did talk to Pascal, who's not in the room, but is a co-author. And he says he thinks everything's incorporated. If it's not, he'll send it to the list. So hopefully we won't have anything. But even if he does, we can capture that as a last call comment. Use cases we'll hear shortly. The problem statement has an asterisk next to it because we've talked a few times that it's a document we spent time on. It'd be nice to publish it. It's an informational document. We spent time on it, so it's good to capture it. But if the text is a little too dated now and it causes us a lot of problems, we may bring it back to the working group and say, do we really want to focus our energies there? Perhaps it's better to focus somewhere else. So we'll see how that one goes. On the agenda, we have 3 of our working group documents that are not yet ready for last call. The security document, Ethan will give an update on that. Hopefully he's online. It's 7 hours earlier there. And the data plane solution is the focus of our second session, but we will have an update in the first session on what's changed since the last meeting. And the flow information model is on the agenda. In terms of our deliverables, welcome Ethan, that's good. Glad he's here. So in terms of our deliverables and milestone, we're actually moving along slower than we had initially hoped, but we're moving along on 3 of the 4 in terms of what we have as adopted working group documents. We don't have any Yang documents or Yang models as working group documents yet, but we do have an individual draft on it that's on the agenda that we'll be talking about today. And with that, I think I've gone through the list. Who's up next? Oh, yeah, so I forgot to mention something. So.
Yeah, in November, we are in a lucky situation that the IETF and the IEEE-802 face-to-face meetings are back-to-back in the same hotel in Bangkok. And we discussed it in this morning as well, that it's an opportunity for a joint session, for the coordination team between IETF and IEEE-802, and we are thinking of as well potentially having a Saturday afternoon joint session with DETNET and 802.1 TSN. This would be the first opportunity to two groups could be in the same room, and I think it would be good for both groups, for a collaboration, and many items are interest for both groups. This is an idea so far. We will have further discussions on the list and so on.
So just clarification. So Saturday before IETF meeting or Saturday?
Saturday after, because IETF is first, then we have the weekend, and then the IEEE meeting.
Norm Finn, right now.
I checked the published schedules, and IETF is first. It's the third, starts on the 3rd of November, and then IEEE-802 starts the next Monday on the 9th. So I think, or Sunday on the 9th. I think it might be that at one time they were the other way around or something, because a couple of people have thought they were in the other order, but I checked online this morning, and it's definitely IETF first and IEEE 802 the second week. Go ahead, Norm.
Yeah, Norm Finn. Right now, the IEEE 802.1 has a joint effort going on with IECSC 65, which is on industrial, a profile for time-sensitive networking for industrial uses. If we can get them to come, that would be a third group that would be, I think it'd be really valuable for them to see what's going on in DETNET, because I think that will be relevant to them as they get into larger networks also. So I'll be pushing to that too.
Right. Well, we did discuss that this morning. We would certainly invite them. Glenn seemed to think that they might not be available for some reason for that, but we should certainly invite them, and whether they show up or not is up to them.
Welcome, Ethan. We can see you, and hopefully we can hear you. When you're ready for me to switch sides, just say slides, say next.
Okay, so can you hear me?
Yeah, you sound great.
Okay, good. So I'm Ethan Grossman from Dolby Laboratories, and this is the update on the DETNET use cases draft. And next slide, please. The current status is that we did put together a use cases draft 14, but it has only very minor changes from the last one. The main one being that we moved all of the authors, which all used to be on the front page, to a contributor section because, as you know, we can't have them all on the front, so that's what we decided to do. Fixed a few typos, basically the same as it was. We consider the draft to be basically stable, ready for working group last call. There's a couple of things that we decided we would defer till the last call process instead of trying to get them into draft 14. One is that there are some text related to network slicing that we've been working on. We'd like to get that in there, but it's just a more clarification. It's good stuff. And I sort of wanted to bring up the topic of whether we should say something in the use cases draft about IPv4, because we've had a lot of conversation about it. And generally speaking, in the use case draft, we don't attempt to suggest any kind of technology or solution. But on the other hand, there was this sort of moment when we realized that for a lot of the use cases, it was important to have at least a solution for IPv4, even if it wasn't the more complete solution you could get with IPv6, for example. I don't know that I want to actually have that discussion now because this is a very short update, but I just wanted to put it out there that that's another thing that we maybe should consider on the list, or if somebody already knows the answer, then we can just be done with that. So so that's the end of the update. We're ready for last call, and that's it. So I did put in a couple more slides if anybody is interested in reviewing stuff about the use case just briefly. One of the things was the notion of the use case common themes. And the only reason I mention it, because we've gone over it enough times, is because it does get referred back to in the security draft update, which I'm going to go over next. So Lou, maybe let's just page through the slides, and I'll spend 15 seconds on each of them, and then we'll just move right along.
The next slides are part of this presentation, or on security,
Yes.
this draft, or on security?
They're in this one.
Okay.
Okay, so the goals, we provide the industry context for DETNet, a yardstick for functionality of any proposed design, and we highlight the commonalities between the use cases. So that's kind of what I'm getting at about these common themes. So next slide, please. Okay, so we're going to go, so future plans, even though we're going to have last call, we're still going to use the use cases draft as a yardstick to consider the value of the proposed solutions. Next slide, please.
Before we go there, Ethan, it's Lou, I have a question. You mentioned earlier that your plan was to go to last call and then to add text. That's not, typically we don't do that. Typically, if you have text that you think needs to be added, we would add it now before last call.
Ooh, I must have misunderstood then, because I thought we had the conversation and that there was going to be, when we do last call, there was going to be one more. Oh, sorry, I must have just misunderstood.
If you have the text ready to go, I think it would be much more efficient for the working group if you do an update and then we issue last call and everyone has an opportunity to review that new text. Does that work for you? How long do you think you need for to get the next rev out with that text that you have in mind?
On the order of a week. The text is basically prepared. It just needs a little bit of editing, honestly.
Yeah, I think it would be much better to hold off last call until that's ready. And then, because as soon as we do last call, we're asking a lot of people to look at the document. And if you then add new text, it means they have to look at it again. And it's less likely to get as good review then.
Okay, that's my fault. I just misunderstood.
No problem.
That's what I thought, but somehow I got a different idea.
A week is easy, so that's fine. So we'll look for the next version and then last call it.
Okay, understood.
It's just Stuart Bryant. Is the
Name,
confusion?
please. Name, please.
Stuart Bryant. I said.
Oh, I didn't hear.
So
The acoustics
is
here
the
are not great.
confusion that the acoustics are horrible? Is the confusion that actually quite often another rev is spun as a result of the last call comments? So there will probably be several more revisions afterwards. It's just that we should start with the cleanest text.
Yeah, I think I heard what Stuart's saying, and it's a good point. It's not that the last call comment, the last call version is the final one. We may have updates based on last call comments, but if the authors know that there's text that have to go in, we shouldn't start last call until that text is there. Ethan, does that make sense?
Yeah, I guess I was thinking more along the lines that it was a minor enough revision. I thought we had discussed it, but I just must have misunderstood.
Well,
it's
or I
not,
misunderstood.
it's not an issue. I can get the text in there in a week or so, and
Great,
we'll go
thank
from.
you. Thank you.
Do you have an opinion on the IPv4 thing? Is that just a non-starter? Can we just say we're not going to mention that?
It's up to you. Our IPv4 is, I think IPv4 is in our charter. So, you know, the fact that we have to deliver an IPv4 solution isn't surprising. But if you think there's a place to mention it, that's not unreasonable. It's in our charter, so mentioning is fine.
Okay. I'll just put some kind of brief mention in.
Yeah,
Okay.
and certainly it's a good issue to highlight to those in the room so that when they're reading the document, they keep in mind IPv4 and IPv6 and make sure that the text is adequate to cover those cases as well as your own use case. All right, we can proceed.
Okay, so I was just going to, there are two of these slides on that show the common themes, and I was just going to show them again because when I talk about the security draft, I refer back to these. So I just thought instead of having to go back from there, we'd go forward from here. So the point is that these are like the least common denominators of all of the different use cases. Because the use cases are many and they're complicated, we decided that it was good to identify the common elements of them. So we refer to these as the use case common themes. And they have things like it has to be scalable in size, it has to have high availability, it has to be secure, the flows have to be deterministic. I use this deterministic flows isolated from each other. That one I'm going to mention, that specific common theme I'm going to mention in the security update. So that's the only reason I'm pointing it out. Okay, that's it for that. We can move on to security. Okay, this is the update on the security considerations draft. Next slide, please. So the current status is that it's still at draft 1, which is unchanged since the last IETF. The draft is considered currently to adequately cover the general topic of security for DETNet. That is to say, it doesn't yet include the security considerations that are specific to whatever data plane protocols we choose to use. So that comprises what we have to do next is to add the security considerations that are specific to the data plane protocols once those decisions are made. Note that the scope of the DETNet security draft is limited to security considerations that are specific to DETNet, i.e. time-sensitive things that we're not trying to cover anything that's covered anywhere else. We're just trying to focus on these specific things. So that's the update. I thought since it was a short enough update, I did prepare two very brief slides just talking a little bit about the draft and what's the structure of it and part of it that maybe is new and might be worth a word. So let me just spend a minute going over those. Next slide, please. So the overview of the draft.
You have 1 minute.
1 minute. It covers security threats, for example, delay, spoofing, and so on, the impact of those threats. Is it a financial impact, health and safety impact, mitigations, in other words, what do you do about those threats, and the association of attacks to use case common themes. So in this way, we're trying to narrow down the problems of securing a DETNet based on knowledge of the specific application or use case. It's hard because there's so many use cases. So instead of by use case, we organize it by use case common theme, as I was just discussing. So if that particular theme is important to your use case and you're involved in security for DETNet, you should pay attention to that section. And if you do the last slide, this is an example of that. For example, the deterministic flows, one that we just discussed. This, for example, the third paragraph here says a flow modification or spoofing or header modificational control packet modification attack could cause packets from one flow to be directed to another flow, thus breaching isolation between the flows. So this is bringing together the properties of a DETNet with what the effect of a successful attack could do to that particular property. So just an interesting way of sorting that stuff. Okay, I'm done. That's it.
Thank you, Ethan, and thank you for being up at, what, 3 o'clock in the morning, or staying up until the meeting time?
Yeah. Wish I could be there.
Well, thank you very much for participating nonetheless.
I like the background with the bikes there.
All right, I think Balazs next.
Hello, my name is Balazs Varga. This will be a short update on the DETNET flow information model. Thank you. This draft became as a work.
Balazs, you have to get closer to the mic.
Okay. I will do it in that way. Okay. Thank you. So this draft was adopted by the work group recently after the last meeting. And what we have discussed there is that this draft will contain not only the flow information model, but also service information model specific aspects. And practically, this is what we have updated in the draft. So this is what I will show very shortly in the slides. Regarding the service information model, we have identified only the basics. Many things will depend on also on the result of the data plane discussion. So what we have put in the draft in a 01 version is ingress-related information element, egress-related information element, DETNET domain, and service status-specific information elements. And we have also distinguished two types of service over the DETNET domain. One is a layer 2 or TSM connectivity service, where the flow contains Ethernet frames, and this is what we are transporting over the DETNET domain. The other service type is IP service type, where the flow contains IP packets, and these IP packets are transported over the service. The basics of the service attributes were also listed. It is the bandwidth parameters, delay parameters, loss parameters. I think nothing surprising. The connectivity type, which is selecting what type of service connectivity is provided, a layer 2 or a layer 3 connectivity, in order delivery, and the service rank. We have added also, based on the architecture draft, some reference points. This is there in the text in order to have some better further discussion. So they might be removed if we don't need these reference points for the service definition. But I think some of them will be definitely needed. So what we have added is just what we have in the architecture draft, the application flow endpoint, the UNI interface, and the NNI interface. Regarding the service scenarios, we have not added yet the interim results. The two service scenarios, the end-to-end service and the DETNET service, this is what is referred in the current version of the document. And practically that's it. The plan for the future is to incorporate the conclusion from the data plane discussion, because that will impact the attributes. And of course, contributions are welcome. Thank you.
Thomas Eckert. Is there no support for the model where the end device itself also performs DETNET? So, for example, I'm aware of a lot of the video application devices that are, performing something like what we call pref, meaning receiving both streams and are able to merge these. And so I think that the use cases are maybe not explicitly mentioning these details, but obviously these video services. And so I'm wondering how that would be captured in that architecture.
I agree that is important scenario, but let's wait for the discussion on the DETNET data plane stuff.
But the general question of whether or not a host is described in the information flow model, is it there?
They are there, yes.
Right. So do take a look at the host description. Use the mic, please. We definitely have people who are remote.
The UNI is exactly not saying that the user interface is DETNET, that the host is DETNET capable, right? So it's kind of just consuming the edge representation of the DETNET service, which is not the same as the full DETNET, just specifically, I think, for prep.
Yeah, I think that'd be definitely an important piece to cover. And if you have some specific suggestions on changes to the document, remember it's a working group document, please ask for change, and even better, suggest text for the document.
And maybe I think we will need also new reference points for that discussion. So let's discuss it via the mail.
The model should be independent of necessarily a first step that we take. So later on, we're going to talk about some first steps where we make some compromises, but the model should support even without those compromises.
The target is in order to have it practically service provider independent and cover it generally. Yeah, that is the target. Thank you.
Who's next?
I am Xue Song.
You have to get really close, I'm sorry.
Okay. Like this.
But you should stay in the pink box.
Okay. I'm Xue Song, and I will introduce our work about DETNET configuration YAM model. This is the first time of this part work presentation, so we will go to kind of detail and some unsettled issues. And first, I want to introduce the DETNET models and their relationship. We can see from the picture, the user will send the flow data model and service data model to the controller. And at the same time, the network will collect the topology data model and send it to the controller. And the controller, based on these data models, will do path computation and comes out the configuration data model, send it to network. And the network is configured, and the DETNET flows are being transmitted through the network. And the network will collect the status data model and send it to the controller. And the controller will send it to the user. And the user, depend on the current network status, maybe change the flow and the service data model. We can see this picture shows the circle of DETNET control and management. And the blue box shows the flow and service data model is covered by the a current draft, which is just introduced. DETNET flow information model. And our work, DETNET configuration model, covers the red box, including 3 parts: topology data model, configuration data model, and status data model. And first, I will introduce the DETNET topology data model. DETNET topology data model is used for DETNET features and resources discovery in the network. And we do some analysis about the current work in IETF. And now we have network topology data model. And now we have TE data model. And in the TE's working group, we have TE topology data model. And the DETNET topology data model is the augmentation to the current TE topology data model, and including 2 parts: node attribute augmentation and link attribute augmentation. And let's do some detailed introduction. These are the attributes are included in our work, and which is necessary for DETNET, but not in the current DE topology data model. First is the node type. In the architecture draft, there are 3 node types in DETNET: edge node, relay node, and the transit node. And then we will specify the elimination and the replication capability of the node. And we also include the queuing management algorithm, the type and their corresponding basic parameters. Actually, as we all know, there are some queuing algorithm defined in actual IETF tasking group, such as time-aware shaping, credit-based shaping, and CQF, a lot of them. It's not in the scope of the current DETNET charter, but perhaps it is an interesting issue to consider that whether DETNET should have their dedicated queuing management algorithm, or we should do some should have some new queuing management algorithm. Any question?
No, just I'm preparing for later.
Oh, okay, so I will continue. And different queuing management algorithm has corresponding basic parameters. And we also have resource reservation base, which is also has been defined in the TSN, maximum fan-in ports, maximum packet size, and maximum DETNET classes. Let me a little explain about what is DETNET classes. Actually, we should have a DETNET traffic class to distinguish DETNET flows from non-DETNET flows. And the question is whether we should have more than one traffic class for DETNET to distinguish different DETNET flows. That means the DETNET flows have different priority and a different process in the device. And we also define the bandwidth and the delay metric for DETNET. In the delay metric, we just do the delay classification in 3 parts: link delay, processing delay, and output queuing delay. Link delay has already been covered by the current work, and the packet processing delay describes the delay from the packet goes into the device and arrives the output queue, and the queuing delay is from the output queue and the outside the device. So we think this classification is not the only solution, and there may be other opinion. It's open to discussion, but we think it's a general classification for this version.
Yes. Hi, Greg Mirsky, ZT. Yes, my question is on the link delay and usefulness of this metric, because if I remember correctly, these RFCs specifically exclude queuing delays.
Yes, yes.
And actually, that's what we're interested, because queuing delays introduce jitter to the packet. The rest is just physics.
Yes, exactly.
So because of that, link delay is not characteristic. We can calculate link delay based on a distance. So what we need is residence time.
Yes.
And the residence time is not interface. Residence time is measured by ingress-egress of interfaces, how we traverse the node. So it's an ordered pair and ordered characteristic because it's directional. So ingress to egress, that's more useful and helpful information. And we have this already included in SFC document, and preparing some document on more general use of residence time in calculating TE.
Greg, there's maybe multiple ways to measure. You're actually making a comment on the information flow document, not on the Yang model. Because the Yang,
well, it's a Yang model as well, because basically...
Absolutely, but it's derivative of the information model. So the base concept you're saying that here is represented wrong. Please go look at the previous document that was presented and see if you think it's right there. And if it's not, suggest a correction on the list.
Yes,
please.
I just want to clarify. I'm not saying it's wrong. I'm questioning whether it's useful.
Actually,
Well, if there's something more useful, again, it belongs first in that other document, then it'll flow down to this one.
Sorry, I think it's very important to mention that I think the magic of DETNET is it's not the delay is not from measurement, it's from the calculation by the particular queuing management algorithm it used. So it's not measured. So it can be calculated. So the delay is deterministic. I think that's the point, and that is different from other mechanisms, other working group work.
Norm Finn, we've got a new draft, and I encourage you to participate perhaps in the new draft on founded latency, where we'll get into the network calculus and how do you compute, and there are different ways to do it, and we'll pick one that works. I would just like to comment on the more than one DETNET class of service. A great many applications will not need that.
Okay.
But if, for example, I may have a factory floor that may have different kinds of flows that have need to make different trade-offs.
Yes, yes.
So it's easy to certainly please don't exclude having more than one DETNET class.
Okay, sure.
Yeah,
Thank you.
and I have a comment to your questions on the left-hand side. Like a lot of work is going on in 802.1 TSNs, providing the yank for all these queuing mechanisms.
Yeah.
So and as well the delays, like we are in a hop and so on. It would be good to have aligned the two and leverage as much as possible.
Yeah. Sorry, I want to answer response to these comments. Actually, we are open to discussion. There is already some work done in IEEE, and this is a cooperation between two organizations. So it's very necessary to sit in the same room, the old topic. Okay, thank you.
Thomas, what is the benefit of having? I mean, not. So to me, it would be a lot more logical, like we do in many other working groups, to have something like the Yang model be normative for the information model. If it's really one-to-one translation, it seems like we're otherwise just getting ourselves into the additional problem of creating yet another round of bugs mapping the information model to the Yang model, right? So just curious.
I didn't hear the question. I think you were directing that at the chairs, but I'm not 100% sure. Greg, can you repeat the question? Because
I'll rephrase and then he can kill me. Not kill, just
don't go anywhere.
Throw a shoe. So the question is that there is a mechanical way of derive Yang model from information model.
Yes.
So what guarantees that this Yang model will be identical to one that could be derived directly from informational model?
Actually, we should go back to the first picture. It's not the same data model covered by these two drafts. We can see the flow data model and the service data model from the user to the controller that is covered by the information model. And what we care, the DETNET configuration YAM model covers different parts, just like the southbound and the northbound.
What guarantees that?
What guarantees?
That there is no overlap between Yang model derived from information model and these models?
I think it's a good suggestion. Perhaps we should consider the interface between these two models. It is a good suggestion. Thank you.
I'm just talking about getting the human translation from the information model into the data model out of the picture to reduce the places where we can create bugs.
So what is your proposal?
Well, I'm not sure if it would work correctly, right? In terms of if there are so many abstract things in the information model that we haven't captured in Yang, then we have a problem, right? But if everything that we have in the information model is meant to be captured in Yang, why the heck is that not the equivalent then, right? So and that's the normative part, and we only have one place where we can make bugs.
Mark, so I have a comment here. So actually, the topology model is not defined covered in the information model. It's just to define this model to discover information about capability of data work. It's not about information model. Yeah.
I didn't mean to say that there needs to be an information model for every data model that we have, but if we have obviously a data model for every information model, then I question, what's the added value of the information model, other than in creating bugs.
So again, I hope that I'm not contradicting tutorials, because organizations usually do one thing, either information model or data model. Because from information model, it's mechanical operation to derive data model. Making two parts of the same issue, problem, because basically we are talking about part that covers life cycle orchestration, okay, with their service model. Using two different ways of looking, different layers, because one layer is information model, another layer, a little bit, it's like a server to it, it's a data model. The problem is how we guarantee consistency of these two views.
Well, do we need to guarantee consistency is another question.
I think so, yes.
So the intent has been, or the discussion has been, that we have the information model that helps us understand what needs to go into the Yang model. And the Yang model is the thing that actually drives the implementations. So the information model is more about the process that goes in here, while the data model is more about what happens with implementation. And I see that's a controversial statement. Everybody get a whole big people jumping up. That, at least that's how I viewed how we were lining up.
But organizations use information model to produce data models.
Well, that's
So
very true. That's very
we're not
true.
using it?
That's true when they formally define the information model using tools such as UML. We're not doing that. We're documenting it in text form, which means that the only way to translate from the narrative to the actual data model is a human process. And
okay.
That's the way we've been doing it. Whether that's right or wrong, we can certainly debate.
No,
That's where we've been going.
I think that I believe there is no right and wrong. I just might suggest that maybe we need to rename it from information model to information flow or something else. Because information model exactly associated, at least in my mind, and I think that in mind of others, a couple others here, with UML and being able to produce data model as derivative.
Right. So it's certainly in the ITUT context, information models are done in UML. There have been other information models done in the IETF, which are narrative in form. And this one is aligned with what we've done in the IETF before. It's not aligned with what has been done with information models in ITUT. But you're absolutely right. There's different approaches. Why don't we give some chance to some others to talk?
This is Alex Clem. Yeah, just one thing to add to this. I mean, there's an RFC 3444 which explains exactly basically the difference or the relationship between the information model and the data model. And I think basically by referring to this, we can clear up. This will clear up some of the confusion that I think we're having here.
Just one more addition, Balázs Varga. The information model is about the flow. And the Yang model is for configuration for all the details. So from the flow, you will select what to configure in the nodes. And it is not at all mentioned in the flow information model or the configuration related details. This is why we have separated the two documents.
Microphone. Again, yeah, we should be careful about what flow means, because we can look at it as just a specific series of packets, or we can look at it in the broader context of how our charter reads it, where it talks about information needed for flow establishment and control. And that's a little broader than just looking at a particular flow, because it's all the information needed for flow establishment and control.
Right. Again, it might be just certain perception that when somebody mentions we are developing information model, I automatically think that that could be a derivative, that could be a source to produce Yang model. And it's not only IETF that uses this approach. We're creating information model. Some other SDOs produce information model and then out of there mechanically derive Yang data models.
Yeah, so, sorry for bringing this up, and just, the original goal was really trying to ask, is there something we can do to simplify our life, right? So not to have more discussions that are not ending, right? So just, if there are pieces, that we know are going to be mapped one-to-one, right? Is there any way to avoid that we have to always continue to check consistency? Because that's where it came from, right? You said, oh, don't talk about these parameters in the Yang model, go back to the information model, then update that draft, and then basically you can come back to the Yang model and get that draft updated, right? So I mean, that was basically, is there a way for simplifying our life, saying, this is basically the Yang expression of parts of the information model or something to avoid the duplication. That's all.
Yeah, you always have to have a narrative form and then the actual model or module description. And one is more about syntax, one is more about concepts. We've split it in the past that most of the concepts are coming in the information model, and the syntax is in the Yang model.
Yeah, but
so
I mean, we have also enough examples where we're really just, having the Yang model where kind of the logic is kind of the informational part in the beginning, and then all the details of parameters also aren't duplicated, right? They're just in the Yang model part of the document.
So often you'll see a reference in that case in the Yang model where you have basically a normative reference to where that parameter is described. And the problem is that being new, we don't have somewhere else to reference. So either it has to be in the same document or it has to be in a new document. Right, and the approach we've been taking is to have them separate. We could certainly combine the documents if that makes sense, but then that becomes a new massive document.
Yeah. Again, as I said, right, I mean, if it's not, really saving us work at this point in time, right, forget about it. I was just thinking that, looking at these consistency issues, trying to, be as efficient in what we're defining, with the least amount of work should be.
Yeah, I mean, I guess, sure. Thank you.
Actually, we have in the document, if we use the same information from the information model, we will do the reference. So keep them, try to keep them. Yeah.
But I think it's actually a good point because right now we have information split over two places. Yeah. Having it split in two places isn't good. Right? And I think even, hopefully everyone will agree that we really want to capture the narratives in one place and then have the syntax definition in one place as well. Yeah, right now it's a little bit spread, which is definitely not a good situation.
Yeah, we will consider it perhaps. Okay, so I will go to the next slide. And after the introduction of the DETNET topology attribute and the debate of the models, we will go to some introduction to the DETNET flow configuration data model. And there are some different node types which has already been mentioned in the DETNET architecture draft. And the different node types play different role in DETNET network, including ingress node, replication node, transit node, elimination node, and egress node. These different roles also can be mapped to the picture below. And all these different roles can be characterized to three DETNET architecture layers. The first one is service layer proxy, which is consisted of edge node, and its main function is encapsulation and decapsulation. And the second layer is service layer, which is consisted of relay nodes, and its main function is packet replication and elimination for service protection. And the third layer is the transport layer, which is consisted of transit nodes, and it will do congestion protection. And the configuration we defined will depend on the different roles and its function. So here we are. There is the layer of the architecture transit node configuration. And we will include some parameters, including flow priority, flow identification, queuing management algorithm configuration, and explicit route, which is needed to be considered, and it is also mentioned by Lou in the mailing list, is there is a very interesting draft in another working group. It is about the QCR model, and we have do some analysis. The QCR model consists of 4 base YAM models: classifier, policy, action, and target. And it also defines IETF diff-serve YAM model based on these 4 base YAM models. And this part work maybe can also be used in our transit node configuration YAM model, because we can do augmentation to this YAM model and the DETNET features into it. This may be the next step work of this document. And we also, here are some attributes about the relay node configuration. The relay node has main 2 functions, replication and elimination. First, we will do flow identification and specifies whether the flow will do a replication or elimination. If it does replication, we should specify the copy numbers or the redundancy numbers. And after do the replication and elimination, we should end the information of flow identification to guide the packet to the next relay or edge node. Here is an example. Any question?
Yes. So you use term node, but
yes.
Have you considered that this elimination function could be a part of their edge node?
Yes,
of
of
DETNET?
course. Actually, we can see more clear in this picture. We can see there is some overlap of different, which means the edge node can also do replication and elimination, and can also be
Right. So
yeah.
might be better not to refer to it as a node, but function.
Yes, perhaps the name should be considered. Yeah, I think it's a good suggestion. Thank you.
Sorry to do this again. You're making a comment on the architecture document. She's just presenting what is in the architecture document. So the architecture document is about to be last called. If you don't like something that's in there, that'll be, please don't wait for the last call, read it and send comments to the list on it.
Thank you. And we will continue. Here is an example. In the MPLS data plan solution, we will use the S label as the identification. So in this relay node, the flow identification is the incoming S label, and we will specify whether the packet will be replicated or eliminated, or both. And we also have to specify the outgoing S label, which guides the packet to the next relay or edge node. And we also have to specify the output port, which guide the packet to different explicit route. And if we have already done this kind of configuration, what will happen in the data plan? We can see in this picture, the first packet encapsulation, the lowest is the payload, and we have the DETNET control word, and the 1001 is the S label, and the T label is for transmit. And the ingress, the encapsulation is like this. And in the relay node, we can see that the S label is switched. It has been switched to 2001, and which and do the packet replication and guide the packet to the next relay node. And the S label is switched again to 3001, and the packet is will go to the egress. And then we will do some configuration in the edge node. In the ingress node configuration, it should include flow identification, sequencing, packet encapsulation, traffic specification, and perhaps also flow aggregation. Because the flow aggregation solution has not been clearly defined in the data plan, so it is open to discussion. And in the egress node configuration, we will include flow identification, packet reordering, and packet decapsulation. What is the next? Actually, because the data plan solution is being discussed, and perhaps there will be some conclusion today in the afternoon. And so, and also we are we should consider the cooperation with the IEEE data model definition. So this version is just the beginning of the work, and we will have more considerations about queuing algorithm configurations, and will improve the replication and the elimination part, and also the DNS data model, and also ask for more contributions and comments. Okay, that's all. Thank you.
Thank you very much. Any other comments? So as we know, we do have a chartered item to work on Yang models. It sounds like we have a little bit of a some follow-up that needs to be done to make sure that the document is appropriately aligned with the other documents. One suggestion I have there is that if you find that you're just repeating text that's in another document, don't repeat it, just point to the other document.
Yes, yes.
And if you find that you need to repeat it because you think the other document is missing something,
okay.
Perhaps propose to some text to go into that other document.
Yeah, yeah.
And
sure.
So we don't end up having to look in 3 places versus just 2. And then we can, as a working group, decide whether we want those 2 places to be in 1 document or in 2 documents.
Okay, okay.
And personally, this is my, as a personal perspective as working group chair is, I hope you do it quickly, because I'd like to see us have something that we could poll the working group on before the next meeting. I'd like to not wait to the next meeting to do an adoption if we can get there.
Actually, we plan to update this draft very soon.
Yeah,
yeah.
I think the narrative parts are going to be a part that is going to be is a bit of a sticking point right now.
Okay, okay, thank you.
The descriptive parts. Out of just so we have an idea of the room, how many people have read the document? It's an okay number. We could definitely use some more. How many think that after the update that's been discussed, that it would be ready to poll for working group adoption? And keep in mind, an adoption isn't the final place, it's the starting point. So about the same number. So it sounds like it's a good plan, and we look forward to seeing the update, and others, please feel free to review it and send comments to the authors.
Okay, thank you. Please.
Thank you very much.
Thank you.
Yoni, you're up next. If you could join the queue. Welcome, Yoni. We see you.
Yeah, you can hear me?
You're a little low.
Any better now?
Yeah, and we maybe can adjust the in-room speaker a little bit. We have someone who's doing AV for us. So let's continue. Thank you.
Okay.
And just say next when you want to go to the next slide.
All right. So this is the update, quick update on the working group draft on the data plane encapsulations. And the next slide. So we had a bunch of interims, and after those interims, I made a couple of updates, actually 2. The last one was uploaded yesterday, and I took in the what we discussed during the interims and what we agreed on interims, and also the input from some couple of other volunteers who contributed text. So basically from the 2 to 0, so this is after the interim 3, Balazs put a bunch of text about the domain-specific consideration and the draw nice pictures about how the encapsulations go in a different deployment cases. for the routing service and bridging service and so on. And so this was really useful. It probably should clear things up for quite a few people. And then I also added the preliminary text for the simplified IP service. That was the solution that we came up with and agreed after the interim 3. So next one. Then from 3 to 4, so this was a minor update. I just because we also agreed that the native IPv6 based solution that was drafted into the draft is a no-go just because it's an IPv6 only solution and so on. And there was a push for also covering IPv4. So I took this text and references to IPv6 solution away and put some more text, preliminary text to the simplified IP solution. Also, I added a note that in a document that pointed out about the previous work that we had in the very first version of the working group document on data plane, where we had this is pseudowire. In a pseudowire context, we had the MPLS PSN, and we also had the IP PSN, and there we had the kind of, if you want to transport something over IP, you should look these, and so it had the solutions that we had in mind based on the RFC 4023 and 7510. So after the so a bit of history, so just that the we kind of been there already long ago, where we are heading again. So there's a couple of presentations bringing this IP solution, which was basically in the first cut of the working group draft. It was removed based on the argumentation what we had at that time. And after this long route, we came up with, in the interim 3, we came up with this simplified IP solution. So I hope that today we can make kind of final decisions where to head and kind of think that the encapsulations become stable. Okay, next slide.
Yoni, it's Lou. What the point that Yoni made, I just want to highlight because that's going to be one of the important topics that we talk about this afternoon. So keep it in mind and come to the second session. I know it's attractive to do other things Friday afternoon, but please come join and participate in that discussion.
Okay, so this slide just highlights the excellent contribution from Balázs to kind of spell out what is assumed to be visible in a text already, but was kind of hidden, and these things show up the routing service and also the for the bridging service for DETNET. So and the one that I have rounded with the red circle on the right bottom corner is the simplified IP solution. So it assumes that the end system IP, whatever it initiates, stays unmodified, and all the DETNET functions that we have, so the queuing and the bounded latency and explicit routes and so on, they are provided by the transport layer below. It has certain limitations that will come later on. And for the other solutions, so the tunneling and the IP PSN and MPLS PSN, there's a good chance that if we continue on this route, that the sync between the DETNET layer and the end system payload the SIM actually can be unified with a small effort, in my opinion. Okay, next slide. So just reminding the consensus from the interim. So the simplified IP data plane service, the identification, because we don't have anything that we could insert into the application originated IP packets. So we basically settle down with the 6 tuple. So that's the typical 5 tuple plus DSCP for the flow identification. And the addition of DSCP allows you actually kind of distinguishing between different DETNET flows, and also kind of also builds the kind of basics for the aggregation of DETNET flows. And as I said earlier, the underlying link subnetwork is responsible for DETNET functions. And so these IP packages match onto each hop, and then map to appropriate the DETNET capable link and subnetwork for the next hop, and so on. So pros for this solution is it's simple and doesn't require any from the application IP. The cons is that we already discussed in the last time, and what this figure tries to explain, that we that we kind of lose the end-to-end properties of one of our dear child or discussion points, so the elimination and packet replication. So that cannot be done end-to-end without doing that at the upper layers, so layer 4 and application layer. But that's out of scope of us. So what actually happens that you still have this service protection, but that is on each network segment. So that's a separate. So you don't have the end-to-end service protection at the DETNET layer with simplified IP. You can build that on your higher layers if you want. But yes. Okay. There's a more meat and more details about this in a later presentation, especially the one at the next session. Okay, next slide. And what next? So I think we are in a point that we can split the document. The simplified IP is going to be as encapsulation pretty simple, and the MPLS based. So we can do the clear cut, in my opinion. What I was hoping for, but didn't really happen, is that get an input for the wishes that people want to see in the document. So I'm still calling for the contributors to kind of provide text. It's there in the GitHub. Anyone can go and mock it if they want. So there's still kind of missing things, especially on the kind of detailed behavior of certain nodes and the kind of advanced parts of the behavior. They are boring, so that's why they haven't been progressed. And then something that we probably, and I hope that we discuss today and make a decision whether the MPLS-based solution should also kind of allow IP PSN or just MPLS PSN. So I think we need to have a agreement on this part also. Yep. Next slide. And that's it.
I think that's last time.
Yeah. Questions? Again, we're not going to get into the heavy technical discussion, but if you have a question on where we are in the process or in the document, now's a good time. With that, thank you very much, Yoni.
Okay.
And we'll move on. I believe it's Stuart who's next.
Yes.
Thank you. So what I was aiming to do with this document was to take... That's not working. It's not working?
We can talk very close and see if it works.
This is working?
No.
See if the switch is turned on.
It's all right, we have two more. Thank you.
Is this working? Yes, that's better. Thank you. So what I was attempting to do with this document was to take the latest version of the data plane document as it existed and write it as an MPLS specialist might wish to see it. What the idea was to make it more easily and readily reviewed by MPLS and PW experts. So there's some language difference between the description used in the solution document and the language that one would naturally use in an IP MPLS context, and indeed the language that the operators of such a network would expect to see. So I wanted to get it aligned. This is a possible starting point for an MPLS data plane spec. What we do with it is really up to the working group. So I think it's unlikely that in the MPLS case we will have anything other than the overlay model. I know of no example where MPLS has got to the end system. And so I wrote it really as a multi-segment pseudowire design would look, and the picture I show there is exactly based on that. What I kept finding trouble was I wanted to call everything a PE, and we don't call it that. So we'll have to have a further discussion, I think, about whose dictionary we use. So we had lots of discussions over the months I've been involved in this about where replication happens and where elimination happens. I think the thing that we have to be clear is that replication and elimination essentially happens in the edge nodes and the relay nodes. One of the things that's quite interesting is if this is a pure DETNET system, then there are service labels visible at every node, and the transport labels are always missing. I don't know whether that will lead to a scaling issue, because it certainly led to scaling issues when people tried to map pseudowires directly to LSPs. So the scope of the S label is always the receiving DETNET node. I think that's where I saw we got to with the Yang model, but in some of the earlier descriptions, that wasn't obvious to me. Label is always swapped to the DETNET node because it's always the receiving node's view of the label that you need to use. So one of the issues that I came up with was how do we handle sequence numbers? So is it a fixed 28-bit value? Can we live in an overlay model with only 28 or 0? And if it's going to be anything other than 28, is this a parameter of the wire at setup time, or is it a parameter that's carried within the packet? In the philosophy of MPLS, it would be a parameter of what I've been calling the wire. It will be a parameter of the setup thing. So you do everything in signaling and have an extremely lightweight data plane is the MPLS philosophy. The OAM. Can we assume that we're only going to use VCCV type 1 or something very similar? That is to say, can we assume that we always use the ACH model? Or do we need to support the GAL model in the DETNET layer? These are decisions that we're going to have to take. Flow aggregation. So I put two models of flow aggregation in there because, again, it's not clear to me whether we want to aggregate so that a new S label and control label, a new control label, a new control word is available each time we do an aggregation. If we don't make the control word available, i.e. we split the stack and have two S bits, if we don't do that, then we can't do pref on an aggregated segment. And I think that's something that we need to think particularly carefully about when we go to wide area versions of this, as opposed to local area versions. Payload type. So in PWE3, we just, or PALS, we just used to hoover up everything and send it across. In DETNet, we're going to have some sort of ACL thing, and we're going to have to support, as I understand it, 3 types of packet: Ethernet, IPv4, and IPv6. And it may not be commonly, people may not have the common knowledge here, that MPLS never uses the IP version to figure out what is, what type follows. So we have to have 3 types. And are we going to set up a different flow group, as it were, for each of the types? Greg?
Yes, Greg Mirsky. I would probably restate this, that MPLS never used it. MPLS relied on the first nibble.
That is correct. It never figures out what's, well,
right.
It does sort of figure it out because it does its OAM recognition on the first nibble.
Right, because basically, because in MPLS LSP, IP was one of native payloads, then it was assumed that after we have a label element with an S-bit set, the first nibble will tell us what the payload type is.
But that's not the way MPLS works. MPLS may do an OAM discrimination based on that, well, at least the pseudo I think one does. But no LSP relies just on the nibble. You get the packet on a different ether type, for example.
Well, if you have MPLS over Ethernet,
sorry.
If you have Ethernet, MPLS over Ethernet, so you have MPLS encapsulation.
Yes.
Yes. If you have pseudowire, you use control word.
Right.
If you have GAL label, then you know that you have OAM. But
for the payload itself, other than OAM, we have one different LSP for each payload type.
So I think you actually, this is Lou, I think you're actually both correct to some degree. Yes. You rely on a combination of the control plane, and typically you rely on the control plane. There is a case where the control plane says this is IP, in which you go look at the first nibble to get to figure out the version. Right. So I think you're both actually correct to some degree.
That is the reason why, for example, in control word, the first nibble is 0, and in MPLS encapsulation of beer, the first nibble is 5.
The first, so you're doing ST?
No, so you can differentiate it from IP.
So version 5 is a protocol that was defined by the IETF. I happen to chair that working group.
But yes,
I know it's a trivia question. But
right. Yes. No. That's correct, because it needs to be different from 0, 1, 4, and 6. Other nibbles that already been used.
5 had been used too.
5, yes.
All right, so that's something to take up with Diana. That's interesting. And you all just learned a little bit of IETF trivia there.
But I think the point is that we need to align with the way that MPLS does this. And MPLS sets up a separate spec for V4 as it does for V6.
Yeah, I don't think it says, that's the way it's commonly implemented. I don't think it is actually stated that that's a requirement.
Okay.
I'd have to go look at, and I don't remember LDP well enough. Anyway, I think that's it.
So the question we got.
Okay, sorry. From the standpoint of FAC, yes, it will be different FAC. IPv4 and IPv6 will be different FACs.
Doesn't mean it's a different label.
Right, but the label could be the same, yes.
Yeah.
We clearly need further discussion. So there's a question of how we set up the path. Can we use the PW signaling protocols that we've already got in place for exchanging the labels between DETNet peers? One of the things that wasn't clear to me is how we set up the graph, because it's a graph we need to set up and not a tree or a unicast path. And we don't normally set up graphs in the routing world. So I think there's some more work, thought needed there.
Comment on that. Actually, there is an ISIS extension.
Yes,
for
yes, yes.
that, which is RFC 7813.
Right, we need to see how that applies to
Yes.
this. Yes, yes. Sorry, but you told me that earlier in the week, and I forgot about it. So, I think there's a few things we need to do here, right? We need to verify that DETNET, that we as a working group consider this as an accurate reflection of the design. I don't think it's quite an accurate reflection yet, but we need to make sure that it's an accurate reflection. And then we need to go and get the pseudowire and MPLS experts to review it, because I don't think there's been enough review from those knowledge groups on this piece of work. Then whether we merge this back into the solution draft, or whether we make it a separate draft, or whether we merge this with a draft split from the DP Sol draft, or what we do, that's up to the working group. But what I wanted to do was to try and make sure that we looked at this from an MPLS and pseudowire point of view, to understand that what we were doing matched well with the learnings we've had over the last 20 years. Thank you.
All right, thank you. As we talked about earlier, we're going to be having a good discussion on data plane in the second session. We'll look to, in that wrap up, to figure out next steps. Certainly, as Yoni already said in his slides, he sees there's good text there. I personally see there's good text there. We'll figure out how to bring them all together into a working group document.
I mean, I'm just looking for you guidance from the chairs as to how we move forward.
That we discuss it in the wrap-up section this afternoon.
Okay, great, perfect.
Just a question for clarification, Balázs Varga. On your aggregation slide, where you have
you can go back.
Where you have added additional control
Aggregation.
aggregation.
Right,
yeah,
yes.
This
So,
slide.
yeah.
And here you are stated that pref is possible. I think that there are limitations on pref in that situation, because for that aggregate, you have just that single control word. So it might not be an end-to-end pref in that case.
I don't think you need to do, you don't necessarily need
I think
to do
that's
it.
a good discussion for the data plane discussion. Hopefully we'll get there. We actually are already 10 minutes over, and we have quite a bit of time this afternoon. Hopefully we'll get to this point.
One key sort of thing.
Stuart,
Yeah, all right.
we should take it until later. And Andy, you'll see a clock in the corner. Anything you can do to...
I will try my best.
Yeah, and I'll do my best to try to get the slides. Hold on, sorry about that.
I'm just making sure I stay in the pink box. Okay, I'm Andy Malice. My co-authors are Stuart and Mark and Balázs. So this right here is a derivative work from DP Sol. It's also a derivative work from Stuart's draft that we just heard from. So we use the same terminology, the same abbreviations, and so on. It's basically meant to augment or replace the text that's currently in sections 5.2.2, 7, and 8.7 of DP Sol. It talks about the encapsulation for DETNET packets when carried over an IP-based DETNET infrastructure. And it's not just an encapsulation for IP over DETNET, although that's certainly one of the multiple use cases. So I just wanted to make that clear. It's the encapsulation for DETNET when carried over IP. Whether published as a standalone document or remerged into DP Sol is up to the working group to decide, exactly the same as Stuart's draft before. The authors are fine either way.
I'm going to actually interrupt for a moment, because just as for context for the working group, this is documenting something that was presented, I think, in Prague, and in the solution document, so you can go back there. And at the time, the feedback from the working group is we didn't want to go this direction. And at the interims, we were struggling with this, and this was a discarded option. And so it's good for understanding that this was basically ruled out in Prague. Stuart made the point that this approach was never implemented and we shouldn't head this way. And then we also had discussions. Wait one second. You're free to correct me in a second. More importantly, we had discussions that this did not align well with hosts, and that we wouldn't be able to deliver an end-to-end DetNet service with this approach. And that is what led us towards the simplified approach in the interims. So I think one of the things that would be really good in this presentation is to say, why do you think we should bring it back? So it's not that we shouldn't consider bringing it back. It's just you should articulate why.
Okay. Then, let's just have the technical discussion.
Okay. If I mischaracterized Stuart, I apologize. That's how I read it, and I think that's how others read it. And if we mischaracterized, I apologize. And
let's just have the technical discussion and see whether this is the best approach.
Yes, and also just to talk about what you just said, this is actually the result of the third interim, and I'll be going to that a bit more in the next slide. It's basically a result of the discussion in the interims, especially the third interim, where we decided on the simplified model. Also, there were comments in the third interim and perhaps the previous interims that DetNet is basically, for at least some of the use cases, a non-starter if you can't use it over IPv4, over an IPv4 subnet. So this is meant to basically allow DetNet to be used in the use cases that require an IPv4 subnet.
Don't forget the host. Just bring in,
yes.
Please address host in this too.
Yes, I do that on this slide right here.
Perfect, thank you.
Okay, very good. So basically, this is based on the simplified model as discussed during the interim, the third interim on the 14th of February. Basically, in this case, end systems are not DetNet aware. So that's the host. There's no DetNet header in the host. They typically send IP packets or non-IP application frames over Ethernet, over an Ethernet TSN link or Ethernet TSN network to an edge node, which is shown as the next node over, next to the end system there, which then adds the DetNet encapsulation. So the DetNet encapsulation is not being done in the host. And this is, by the way, the exact same figure that Stuart had in his document and in his slides. I just changed a couple of the labels because it's not using an MPLS subnet, it's using an IP subnet. Other than that, this is the exact same figure that Stuart had in his document, and is based on the figure that you showed, Lou, in the third interim. Okay, so in this diagram, edge nodes and relay nodes are the ones that are DetNet aware. So you can see that we show DetNet end system, edge node, transit node, which is not DetNet aware, a relay node and edge node, which are, and again, an end system, which is not DetNet aware. And the edge nodes is very similar, as Stuart said, to PE routers for pseudowires or MPLS VPNs. Okay. Any questions on this slide? Okay, so what we want to do is we want to take advantage of work that's already been done in DP-SOL. And so basically to transport DetNet over IP, you require a couple things. You require a method to identify the DetNet flows and a method to carry the DetNet sequence number. Well, both of those are already available in DP-SOL, in the MPLS encapsulation. So this is just copied directly from DP-SOL. As a reminder for people, this is the DetNet MPLS encapsulation that's currently in DP-SOL. The control word has the sequence number, and the S label identifies the flow. So the IP encapsulation is very simple. For transport over IP, the transport labels from the previous slide are replaced by UDP and IP, as specified in RFC 7510 for carrying MPLS over UDP. The encapsulation is added and removed in the edge nodes. Okay. So notes on this encapsulation. First of all, it works equally well with IPv4 and IPv6, just to show you right there. That IP header down the bottom, that could be either V4 or V6. Everything works just fine either way. It works with MPLS-based segment routing as specified in IETF Spring Segment Routing MPLS. In that case there, the T label that you see in that picture right there is retained in each segment endpoint. The top T label is popped and mapped to a corresponding UDP IP tunnel. So the next steps are to either, as the working group and the chairs prefer, either merge this back into DPSol or to continue as a separate draft. And that's it. Any questions?
No, I don't have a question. I do have a clarifying point, which is the assertion that this encapsulation string can't be used in a host. From a host point of view, the UDP piece down would look like a socket call, and the piece above it is just some magic numbers in the host payload. So I don't honestly see why we can't use exactly the same thing from a host as well as from an edge.
So the discussion is that we're inserting between the transport protocol, the IP transport protocol, let's say UDP or even TCP, even SCTP, I don't know, but between UDP and TCP and IP, and that's not an easy thing to do in most host stacks.
Oh, well, because you think the host has already put UDP on it before we get it?
No, the application makes a socket, like a POSIX socket call.
Yes.
And then we have to insert our header in the middle of the stack.
Well, indeed, but I wonder if we could persuade the application to insert just some magic bytes in front of its output, and then we'd be done.
I think the feeling was that, we operate on consensus a little loose, was that wasn't a reasonable ask, and if we did that, we certainly would have to coordinate with the transport area, because we're now mucking with basically the transport interface.
Right.
And that was viewed as too complex. Now, the approach taken here, to me, sounds like it's just taking the MPLS solution and running it over an IPPSN, which, that's just, MPLS over IP. We know how, we just need to make sure that we do it consistent with how the whole industry does it now.
Yeah.
Sure. That sounds reasonable, but taking it to the host was where there was a lot of pushback. And in particular, we wanted to make sure that we didn't forget about V4 hosts, and some of those hosts are and this is, I think, something that came out of JL's presentation or maybe some side conversations, is there's a lot of devices out there that are embedded devices where it's really hard to go change the stack, and we want to support those too.
And just to be clear, taking it to the host is not a part of this draft.
Oh, indeed.
Yeah. So Greg Mirsky, ZT. So I understand the idea is similar, or might be as a derivative of unified segment routing.
Yes, it's similar to that.
Okay. So when we discuss the host, we need to understand, and then we'll need to extend IGP segment routing support to the host to participate in this.
If we ever take it to the host.
Yeah. So basically, whatever.
Which we don't know.
Right. Whatever edge of DETNET domain is, it has to use IGP segment routing protocols extensions.
Sure. And again, that's just if we want to do segment routing at the host, because you don't have to.
I'm going to, actually, Yoni was in queue.
Okay.
And he actually was in queue after Stuart, and I apologize, I missed him.
Okay.
So Stuart, I think this is in response to you. Yoni says, it is doable. One can view it as tunneling. Stripping the additional IP header away was the hard part for the host. That was his view of the host.
Okay, I mean, I was talking to Yakov just here, and he thinks there's another way of doing it. So
yeah.
I think we need to have the discussion. This is not probably the time to have the discussion, but we do need to get into these discussions as part of the design process.
Okay.
Thomas, yes, I heard something here about inserting this header in the middle, and to the best of my knowledge, if the host generates IP packets, then I don't see a way today allowed by the IETF to not have basically two IP headers, right? So your IP header from the DETNET, and then, the payload packet would have to have its own IP header, right? You look at Roll and others that have tried to insert things in the middle, and they failed on the constraints of the IPv6 architecture. Before, you're not allowed to do before, and you're not allowed to change IPv6, so this is going to be, two headers, unless really we have, a model where DETNET goes all the way to the host, and then of course, the host stack can do whatever it wants, and then you would get away with just one IP header. I wish it was different, and maybe, we can try to fight the windmill. I'd love to, but...
Hi, I'm Xiaohu from Alibaba. I just noticed you are talking about how to use MPSSR over IP encapsulation for .NET. If so, I suggest.
Could you speak louder, please?
Closer. I believe this format is almost no difference from the MPSR over IP encapsulation, right?
Yes.
So the difference is on the control words layer, but this is the original .NET MPS encapsulation.
Yep.
Right. So I suggest to add a reference to the MPS over IP draft in this in your document.
Yes, that's
because there's no need to describe those details which have been described in another draft.
Yes, exactly, which is why I referred to Section 3 of RFC 7510, which is the description of how to do MPLS over IP.
Okay.
So we have failed at at speeding up the discussion. We will resume data plane discussion this afternoon. Thank you, Andy.
Okay, thank you all.
Torles, and we really need to ask you to squeeze time.
So this is basically a presentation about, a forwarding plane that was,
You have the clicker.
The
Closer, closer, right? You have to eat the mic.
Okay. Okay. No, this should be working. Right, so this is basically a quick overview about the here and specifically with traffic engineering forwarding plane that we're developing in the working group.
Got switched off and I got put back.
Yeah, okay. So I don't think we have talked much about multicast forwarding planes, and I could as well talk about the existing multicast forwarding planes, but given how DETNET is a future architecture that we want to build, we wanted to kind of show what we think is the the best forward-going multicast forwarding plane, giving traffic engineering and everything else, and we're just also in the process of bringing into that work the elements that we think are missing for DETNET. So in beer with traffic engineering, what you effectively have is that every adjacency, every link in the topology, it has an address which is a bit that you ultimately insert into the header, so that you can engineer the path by simply having every node in the network looking at the bits that are its own adjacencies and are forwarding and replicating towards them. So if you see here, there is this red path with the bits 2, 3, 4, and 5 meant to deliver traffic from PE11 to the receivers PE2 and PE3, and that would effectively result in a BRTE header with exactly these bits set being sent from the source, which we call the ingress BFR beer router, and being forwarded along that path and replicated toward these receivers. So that's really a very simple thing, and these bits are per packet, so at that level we don't have any notion of flows, so the sender is free to choose that on every packet. Now, when we look into what we think is missing for DETNET in the forwarding, that's primarily the aspect of pref, or however we call it now. And so in this example, what we're showing is that we do have two alternative paths, right? One going through P1, one going through the other part of P3 and P4. all these bits being set. And the elimination function itself is something that, as we said in the architecture, also can happen in the middle of the path. So, these bits being set, the elimination function, of course, for its operation needs to have a context, which I, call the sequence number space here, and then the sequence number associated with the packet. How we construct the sequence number space is something for us to work out. We currently have two fields in the beer packet header that are filled with the source and, a random part, which I call the selector. So that would be a good part to define that sequence number space, then the sequence number itself, obviously. And with the ability of the elimination function to happen midpoint in the network as, provisioned for the DETNET service and not only on the egress, you can also, and this is the next slide, by the way, see that you can sustain arbitrary level of failures depending on how much, path you provision. So this is basically the example where you have two consecutive failures on different path, right? But you would still support it because the elimination function helps you to basically overcome this amount of failure.
Yes, Greg Mirsky, ZT. I just wanted to ask you, so you do realize that the proposed format for BRTE DETNET is incompatible with the beer encapsulation.
So this is exactly the new proposal of the beer header, which adds the control word sequence number, right? So that's exactly what we need to work through.
Right, but I think that then you cannot really refer to it as a beer because it's not with the 8629 RFC that defines the beer.
We look forward to hearing the results of that discussion in the beer from the beer working group.
Right, because then you have a problem of how you encapsulate it in Ethernet because you cannot use either type that's reserved for beer.
No, I think that's exactly, whether we want to reuse the existing ether type or call it a V2 of that or assign a different ether type. So I think that's good work to figure out. But I think it seems to be clear that the control word that we need for pref is a similar element in the headers as we have for other services, right? They're not needed for the actual beer forwarding, but for the overlay service that we're running here, and that would be the DETNET service. So that's basically the resilience, the pref part. I think, given how DETNET, targeted for layer 3 environments would get into topologies that
1 minute.
Yep, are not that common in the TSN case. So I'll skip the OEM stuff. This is basically an example that you can read on your own time, given how I'm shut down, to basically show the efficiency that we get with the EF in typical layer 3 topologies like rings. And that's basically exactly the considerations where we said elimination function is on ingress. And then, of course, the whole, traffic engineering architecture, PCEC managing the bandwidth and providing calculation of the paths. So that discussion has started in the TEAS working group. Yep. Also, we're looking into allowing to do the pref in beer itself. There's basically the path engineering resilience discussion because we'll have to rely on IGPs as opposed to on a PCECC. And yep, those are the references.
Thank you. And just to make you feel better, Norm gets half his time, and his is actually within charter scope, while yours is not. So gave you more time. Actually, I made an incorrect statement. If someone wanted to work on beer, DETNET over beer, we could consider that as charter scope. It's not what we're going to do initially. So it's not that it's out of scope. Excuse me.
Just a reminder, I find it handy when people are in the room. What we care about is upper bound on latency, not low average latency. If we have bounded latency, we can compute how many buffers we need to get zero congestion loss. Any scheme that uses feedback to slow down the source is not an option. We have fixed bandwidth. We have minimum bandwidth required for each flow, and mathematically sound assurances can be given on latency and congestion loss. We're not interested in probability. So given that, most of the DETNet work we've been done has been talking about packet replication and elimination because that's more a fun topic. Everybody has an opinion. There's lots of ways to do it, but it's not a trivial problem. So that makes it really interesting. And it's very similar to existing uses, and MPLS is a familiar technology, so everyone has an opinion. Okay? Well, this isn't the only thing in DETNet. Bounded latency is the most important feature to most of the application if you look at the use cases document. What they really care about is bounded latency, and we've talked almost not at all about this. Because random unexpected congestion is exactly what prevents mixing critical traffic and other traffic in one network. And that's one of our important goals, is to do that. We've done this in IETF a long time ago, a very long time ago. IntServe was done, but IntServe, quote, doesn't scale, and queuing calculations are pretty complicated. Well, the IntServe technologies do work. Hardware is a lot cheaper now than it was in 1995. There are also a number of new queuing and transmission selection techniques besides those that were explored in IntServe that offer different trade-offs, and there are an awful lot of trade-offs in this space, and I'm anxious to get us talking about them, between low latency, latency variation, implementation collection, complexity, and the complexity of what you have to do to make a reservation. Okay? There are all different places in those in that four-dimensional space for sweet spots for solutions. And now, if you remember in Singapore, we got a presentation from Jean-Yves Le Boudec, which was very exciting because he's one of the people who have pretty much invented network calculus as we know it. And we believe that we can do the necessary network calculus in a way that doesn't require a PhD to do a thesis for each flow that you set up. So we've got a new draft in here, bounded latency. I drafted a bunch of it. Jean-Yves has put in a lot of work to it. It has an introduction. It has a section on network calculus, which will be greatly expanded in the next 2 or 3 weeks, I believe. We have a section on what it takes to compute the necessary buffers. We have a section that may be too large on queuing models. At some point, we need to map. We need to make a select. I believe we want to make a selection of queuing models, or at least going forward, anyone who has a queuing model that they want to use for DETNet needs to be able to map their queuing model to the requirements, to the parameters that we're going to have in this bounded latency document. The most important section, I believe, is section 8, which is how to characterize queuing models so that you can compute the latency for a flow. So this is very much a work in progress. We're certainly not ready to adopt it by any means yet. It's a start. Those who have an interest in this are encouraged to participate. So I encourage people to join me and Jean-Yves. If you feel you need to write something totally different, I certainly can't stop you. It'd be more fun if we worked together, I think. Thank you.
Thank you, Norm.
Thank you. Thank you for moving it along.
I know how to
Norm,
follow
quick
up.
question.
Got a question?
Yes.
Just a clarification, Kiran from Huawei. So when you compute these queuings, they will be the outcome of bounded latency, or you will determine the queuing models and then compute the latency on top of it? Which way will it go?
It is a somewhat complex problem. The expectation is that a given application, a given flow, has a requirement for end-to-end latency, okay? And that you have to reserve resources in the network for that latency. And that maybe we haven't gotten into control plane issues. At the very least, using the Yang models that we're developing right now, we will be able to have a central controller make inquiries of the network and be able to construct a yes or no. Can we meet that latency? It will be, a central controller will be able to compute the latency that can be achieved for this flow. Okay, whether we have a protocol that goes end to end along the path to actually reserve the resources, or whether that's done with a controller, that's to be determined.
Okay,
Does that answer your question?
Not really.
Okay, try again.
Queuing models are per node basis, isn't it? For each
Can you get closer to the mic? Yes, thank you.
For each node, you will determine the queuing model, because queuing is specific to a node. It's not network level.
The expectation is that we have a timing model that includes queuing delay. Okay?
So we should let the next presenter talk.
Okay.
And if we have time, this is, I don't think we're gonna have time this afternoon to get into it, but it's an important discussion that would be great to take to the list. It is an important enough discussion that if we want, we can even schedule an interim just on this one topic. Once we're settled out on encapsulations. Norm, would that work for you too? Just give a thumbs up. All right, Norm wasn't listening, he has no idea what I said, and he gave a thumbs up, so that's awesome, thank you. All right, he was listening, multi-track brain. Okay, please go ahead. Thank you.
Hello, this is Yuan Long from Huawei. We are talking about the net of the RAN topologies. The background of the multicast service, as we can see in the use case of the DETNET, there are some use cases around the multicast, and it said the multicast capability should be integrated into the DETNET. Another thing is multicast and broadcast is a key enabler for the 5G. And we can see quite a few use cases relied on the multicast capability.
So just to make it clear, you have 4 minutes total.
Sorry?
You have 4 minutes.
Oh, sure.
Maybe not to spend too much on background.
Sure. As we can see, most of the access network and aggregation network are using the deployed by the RANs. This is a real network scenario for a city. The traditional, we can use the P2MP service in the MPS to provide the P2MP service in the RAN. If there's a failure in the RAN, then the service is wrapped up and into another direction, so that the service can get around the failure. That will bring a delay of the service, which may override the constraint of the delay. Well, this document proposes another solution. So we can use DETNET technology here. As you can see, when the service is going to from the root to node A, then it's replicated into two directions, one in the clockwise and another in the counterclockwise. And then each node around the RAN will process it by the LSP and then the third wire layer. Now it's called the service LSP, or service flow label. And then the node attached with the leaf will do elimination and replication there, so that the service has only one copy to the leaves. This is another scenario for the interconnection of rings, where the root service is replicated in the node A upon the ingress, and then it's replicated and eliminated in the interconnection nodes, and then replicated over both direction of the ring in the second ring. So as we can see, the multicast in the DETNET ring is very efficient. At most, only 2 copies of packets is sent over the ring. This solution is also very compatible with traditional DETNET. As you can see, it's almost gray QoS for DETNET. And both unicast and multicast can use the same mechanism, such as the replication and the elimination. The only issue may be since the ring has an intrinsic asymmetric path, so this may play a constraint on the maximum packet arrays of the service, especially when the sequence number is not very long, for example, 16 bits. So as this is a preliminary job, so we would like to request more feedbacks on the work group.
Thank you very much. We are now at the end of the first session. I see people in line, and this is great. Let's get the comments sent to the mail list.
I just want to point out that it's hardly can be called efficient because you are not using physically disjoint network and you are cutting your bandwidth in half.
All right. I look forward to the discussion, or we look forward to the discussion on the mail list. And with that, it's break time. We're going to come back at 11:50 and then go for about 2.5 hours. So take your break and then come on back. I think they usually do little sandwiches at this time, so go find them and enjoy the break. And we'll see you.
Breaks up in the mezzanine.
We'll see you in 20 minutes.
Well, we can talk offline.
Yeah, please continue the discussion on the list. It's all uploaded. Yeah, so let's go. Yep, so we're set. Let's go. Let's go upstairs.
I mean, do they give you sandwiches?
Yeah.
Little finger food.
Hi. Oh, how are you? Yeah.